Hello, I'm starting today the first part on section 6.5 on exponents and scientific notation. So the first part will be on the properties of exponents, and the second part will be on scientific notation. So first, we need to know that an exponent denotes repeated multiplication. So you have something like 3 to the 4th power. For example, 3 raised to the 4th power. That 4th power indicates that 3 is multiplied by itself 4 times. So in general, or 10 to the 5th power means that we're multiplying 10 by itself 5 times. And 10 multiplied 5 times is going to be 100,000. So I'll copy the definition from the book. That's page 282. That says that says that if A is a real number and N is a counting number or a natural number, then A raised to the N power is going to be a product of N A's. The number A is called the base, and the number N is called the exponent. So I'll copy the first example from the book. We are evaluating the expressions. So same page, 282. Write each of the following expressions in another way using the definition of exponents. Then evaluate the expression. So the first one, a product of 5 threes is 3 to the 5th power. And if you multiply 3 5 times, it's going to be 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And 81 times 3 is 243. B, 2 to the 4th power is a product of 2 fourths. And a product of 2 fourths is going to be 16. Part C, 0 to the 6th power is a product of 6 zeros. But any number multiplied by 0 is a 0. And 0 multiplied by itself 6 times is going to be 0. D and E, we just need to be careful with grouping symbols. Negative 2 to the 4th power is a product of 4 negative 2's. Okay, negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. And negative 8 times negative 2 is going to be 16. Any party, just be careful with the grouping symbol. Negative 2 to the 4th is the opposite of the product of 2 fourths. And part F, any number to the first power is going to be the number itself. That is, we're multiplying 5, well, only one, so we only have 1 5. Okay, so we have several rules for exponents. that I will mention one by one. The first rule is the product rules. Is the product rule for exponent. So we're still on page 282. If x is a real number and m and n are natural numbers, then x to the m times x to the n is equal to x to the m plus n. And as a note, the rule doesn't work for different bases. In general, x to the n power, I should write, the rule does not work for different bases, such as x to the m times y to the n. So if applicable, we're going to use the product rule. For exponents to rewrite each of the following expressions. To evaluate each of the following expressions. One, 3 to the fourth times 3 to the sixth. Okay, so the product rule says that 3 to the 4 times 3 to the 6 is 3 to the 4 plus 6, which is 3 to the 10 power, and we're multiplying 3 10 times. On a calculator, you can evaluate this. So I'm opening the calculator. Okay, on a calculator, we're going to hit 3, and then the symbol, 10. And 3 multiplied 5 times is going to be 59,049. Okay, so this is what you do on a calculator. Different calculators have different buttons, but it's going to be something like the button 3. And then you're going to have a symbol like y to the x, or you may have a symbol that looks like this. A symbol looking like that, it really depends on your calculator. And then 10. And B, if applicable, use the product rule to evaluate each of the following expressions. 2 to the fifth times 5 to the third. So the product rule is not applicable because the bases are different. The product rule is not applicable because the bases are different. So we're going to evaluate this directly. We have what? We have 2 to the fifth power. That's a product of 5 2's. And a product of 3 5's. But to multiply 5 times is going to be 32. So this is 32. And 5 times 5 times 5 is 125. Finally, 32 times 125 is 4,000. Okay, the next rule. Here's the situation. Let's suppose you want to evaluate you want to evaluate 2 to the third power raised to the fourth power. The product rule says that this is 2 to the third power multiplied 4 times. Or not the product rule. The definition of exponent tells you that this is 2 to the third multiplied 4 times. And the product rule, according to the product rule, this is 2 to the 3 plus 3 plus 3 plus 3. At the end, this is the same as 2 to the 3 times 4. That's 2 to the 12. If you evaluate this in a calculator, that's going to be 4,096. So this is 2 raised to the 12th power. And that is 4,096. So here's the power rule for exponents. We did the product rule. The next rule is the power rule. Okay, on page 283. If x is a real number and m and n are natural numbers, then x to the m raised to the n power is x to the m times n. So we are going to use the power rule to evaluate some expressions. Use the power rule for exponents to simplify each of the following. Number 1, three to the fourth power raised to the second power. By the power rule, this is 3 to the 4 times 2. 3 to the 4 times 2 is 3 to the 8th power. And 3 to the 8th power, if you evaluate on a calculator, that's going to be 6,561. And B, -4 to the 4th power to the 3rd power. Power rule says that this is -4 to the 4 times 3. So that's -4 to the 12th power. So we have a grouping symbol. If you evaluate on a calculator, make sure you're grouping the base. So this is -4 raised to the 12th power. And that is 16,777,216. Next case scenario. Let's suppose you need to divide an expression such as, let's say, x to the sixth over x squared. Okay, so we're going to use the definition of exponents. X to the sixth is x multiplied 6 times. And x squared is x multiplied twice. Okay, we can cancel a couple of x's. And we got x. Actually, I multiplied this 7 times. I multiply an extra x. So this is a product of 4 x's over 1 or x to the fourth. The general rule is that if you have a quotient of powers with the same base, you can subtract the exponents. So this is page 284. The quotient rule. If x is a non-zero real number and both m and n are natural numbers, then x to the m over x to the n is x to the m minus n. There's a couple of consequences. So the above has the following consequences. So let's suppose that m and n are 4. Then from the quotient rule, you know that this is x to the 4 minus 4 or x to the 0 power. And using the definition, x to the 4 over x to the 4th, well, if you're dividing a number by itself, the number is going to be 1. So that's the first consequence. And the other one, let's say that the numerator is less than the denominator. Let's say that m is 2, and then it's fine. Then, using the quotient rule, x squared over x to the 5th is x to the 2 minus 5, or x to the negative 3rd power. But on the other hand, if we use the definition of exponent, x squared over x to the 5th is a product of 2 x's over a product of 5 x's. So 2 of those cancel out, and we have 1 over a product of 3 x's. Okay, so this is what we got. In the first situation, we got that x to the 0 equals 1. In the second case, we got that x to the negative 3 is the same as 1 over x to the third power. So a negative exponent indicates a reciprocal, and a non-zero number raised to the 0 power is 1. 0 raised to the 0 power is undefined. We're not going to get there, but just for you to know that 0 to the 0 is undefined. That's on page 284. If a does not equal 0, then a raised to the 0 power can be positive or can be negative as long as the number is not 0. As long as the base is not 0, any non-zero base raised to the 0 power is 1. And if n is a natural number, then a raised to the opposite of n is 1 over a to the n. So more examples with the quotient rule. Using the quotient rule, evaluate the following expressions. And write your answer as a single number. Without exponents. A 3 to the 8 over 3 to the 5th. Yeah, looks like I'm not writing complete numbers. That's 3 to the 8 over 3 to the 5th. This is 3 power rule, not power rule, quotient rule. This is 3 to the a minus 5. But a minus 5 is 3. And 3 to the third power is 3 times 3 times 3. So that is going to be 27. Part B. 5 squared over 5 to the 4th. From the quotient rule, we know that this is 5 to the 2 minus 4, which is 5 to the negative 2. But a negative exponent indicates reciprocal, so this is the same as 1 over 5 squared. And 5 squared is 5 times 5, which is 25. And part C, well, for part C, you don't need the power rules. Let's say 13 to the 11 over 13 to the 11. Well, you know that this is 1 because you're dividing a number by itself, but it's still, if you wanted to use the quotient rule, this would be 13 to the 11 minus 11, or 13 to the 0 power. Any number to the 0 power is 1, but you could have evaluated directly, knowing that a number divided by itself is 1. And the last thing I'm doing in this video, I will continue the next video with scientific notation, is that the rule also works for negative, the rules also work for negative exponents. We're going to simplify the expressions. first expression is 4 to the negative 3 times 4 to the 5th. So we're using the product rule. This is 4 to the negative 3 plus 5. 4 to the negative 3 plus 5 is 4 squared. And 4 squared is 16. It's 4 times 4, which is 16. B. Power rule. 3 to the negative 2 raised to the 4th power. The power rule says that this is 3 to the negative 2 times 4. But negative 2 times 4 is negative 8. And 3 to the negative 8 is 1 over 3 to the 8th power. 3 to the 8th power, we already did this. This is 6,561. RC. Negative 2 to the negative 3 over negative 2 to the negative 8. Quotient rule. This is negative 2 to the negative 3 minus negative 8. But negative 3 minus negative 8 is going to be negative 3 plus 8. Or negative 3 raised to the 5th power. Negative 3 raised to the 5th power is, let's evaluate that. Well, that's negative 243, but we're going to evaluate this in a calculator. That's negative 3 to the 5th power, and that is negative 243. And part D. That's the 0 power. And you know that a number divided by itself is 1. But let's suppose you still want to use the quotient rule. This is 21 to the negative 14 minus negative 14. But negative 14 minus negative 14 is 0. And any non-zero number to the 0 power is 1. Okay, so that's the first part of the section, or rules of exponent. The second part is going to be scientific notation, which we're going to cover next time. Thank you for listening.